Hi, this video will be about the Micro 810 PLC from Allen Bradley and the software that you're going to be using to program it, which is CCW. This PLC is a smart relay with many math instruction, and it comes with 4 outputs and 8 inputs. If you scroll down, you will see the option how this PLC comes. It comes with 8 inputs from 120 to 240 volt AC or 12 volt DC or 24 volt DC AC, and 4 outputs can be relay outputs or 24 volt DC source output controller, not relay. This PLC comes with 2 auxiliaries, the USB adapter, which is you have to be able to communicate with this PLC and download the program, or the LCD. The LCD, it's optional. You don't have to have it. It's right here. It's this LCD, and I used it just. You can use it to change timers values. You can monitor the inputs and outputs status and some other functions. So it's helpful, but it's not a must. But here, where the USB adapter comes, you have to have it. Otherwise, there's no way to communicate with this PLC. As I said, this PLC will need the Connected Component Workbench or CCW software to program it. And we will be talking now a little bit about this software. You will have a free account you have to create a free account with Rockwell, and then you will be able to download this free. Here, when you open this software, you create a new project by selecting new. You name your projects and you put the location to save it, create. It's gonna prompt you to ask you, what do you want to program? In my case, I'm programming Micro 810 PLC, the 12AWA. I select it and I add it to my project. Here's my project open. It shows me my PLC, and if I want to download, upload, if it has already a program, you can upload. If your program is ready, you download. It's gonna stay right here in the tab. This will stay there in case anytime you want to come back to this screen. In our case here, I will go to main task and I will select add and then select what language I want to program my PLC. You can program it with structured text, ladder logic, function block. Ladder logic. It's opened this first routine for me, and it named it program 1 as default. You can change it, right click and rename. You will name it to whatever name you want. With every routine or program that you create, it comes with local variable. You can create a local variable for it, for this specific program, or you can use the controller variable to use in your program. And what these are the holder for the tags. This is the memory area that is going to hold the tags. It can be local or it can be global or controller variables. The difference, the controller variable, you can use them in any program and any subroutine that you created under this program. For example, I'm gonna rename this. It's just because they have this named as a program, so I'm gonna rename this main, for example, for now. And then I'm gonna create another one. So this reserved, so I'm gonna call it sub 1. So now main routine or program came with local variable, and sub 1 will come with its own local variable. Right now, this area of the memory is the PLC, it saves this memory area just for this main, and it saves this local memory area just for this sub. So which means if I want to create double click on this and create a tag here, main, you name it, whatever, main 1, and now I have this tag inside the local variable. I cannot use this main 1 tag inside my sub 1 subroutine or program. Whatever I build inside this program, I cannot use this tag. So inside, I double click my main, and right now here it shows me the tools that I can use to program my new PLC. They show the general one in the top, and they show them all here in the right. But here you can switch between the one you want to see in the top. So here, favorite, for example, I take the normally open contact. It open when I just dragged it down here to this line, it will give me this screen. And here, this screen is going to show me if I have tags inside the global variable, and global, this is the controller variable, or if I have tags inside the local variable for this main, and it shows me this is for main. Or if I want to use the system variable, if I want to use the IOs, the inputs and output, or defined words. So the user global variable are all the tags that I'm going to be creating inside the controller variable. The local variable main is all the tags that I'm going to be creating under the local variable under main. And because I'm inside the main program, it's going to show me only this. It's not going to show me the local variable for sub 1. System variable are tags that generated by the PLC, by the software itself, I mean, and that you can use if you need to. One of them, like one important one I use a lot of time, which is the first cycle, first scan. This one, for example, this is it turn on. I can use that only if I need something to turn on or off in the first time the PLC goes to run mode. If you turn on or you switch between program run mode, this tag will turn on only the first only for one time, and after that it never will turn on again until you turn off the PLC or switch to program and switch back to run. So sometimes I use it to let me know this is the first scan or something like that. So these tags are generated by the software by default, and you can use them if you want to. The IOs are 4 outputs built in with the PLC and the 8 input built in the PLC. And I can use any one for this one. For example, for now, I'm going to use the tag that I created under local variable, which is the main one. And also if I don't want to select the tag here, I cancel, and here I can come and say whatever tag I'm looking for, and here I go. I delete it now. So this is my normally open contact. And now, for example, under sub, if I want to go to the sub, and the same thing in my rung, and that's what they call this rung. Every line they call a rung. I can add another rung here. I have 2 rungs now. So in my first rung, if I want to add another normally open contact, and I go to local variable, now it's going to show the sub 1 local variable. It's not going to show me the main anymore, and I don't have that tag that I named main 1 anywhere I can use here. So I have to create another tags for this. I can create the new tag under the global, and that way it's going to be here, or I can create it under local, and I can write the tag right now here. So I'm going to say sub 1 tag 1, and okay, and here you go. Now here under controller variable, it's going to show me all the inputs and outputs, the system tags, because all these are global. The inputs and outputs and the system tags are global. You can use them in any program, so they are under the controller variable. let me add the tag here. We'll call it test. Here we go. So now if I go to my main program, create a new one. Under global, I see my test tag now. I can use it under here. And if I go to the sub, again, the same thing. Under global, I see the same tag too. So I have my test tag inside the sub and inside the main. And as you notice here in the tab, when I told you you can go between these tabs, here's the micro 10 tab, the controller tab, main tags, and the main program, and the sub tags, sub program, and you can close those if you don't want them. That's fine. Save, yes. I don't need those tags, so here you go. All right. So now we're gonna talk more about these tools. Here in the right, I can see all of them. I can see if I want to add wrong instruction block, and I'll come back to it now. Return, jump, branch, direct coil, and reverse coil, set coil. So I'm gonna go quickly about these, the difference between the main important ones. The main important ones is normally open contact, normally closed contact, and the coil. So this is present the output, and this is present the input. If I select this one to be one of the inputs in the PLC, so whenever I push this button, and this is normally close, so whenever I push this normally close, this input turn on, it will open this contact, and it will not let the signal to go through to turn on my output. But if it was, let me select normally open for now. But if it was normally open contact, whenever I push this input, if it's push button or switch, whenever I turn it on, it will turn this contact on and let the signal go through to turn on my output. So the simple program I will have is, if it is like this, I have an input, I have an output. If I push this input, turn it on, it will turn on my output. If I let this input off, my output would turn off. Another example, normally close. I can cancel here, and I come here and select which input I want to use. Input 2, for example. If I now, and here let's put an output. Let's select it from here, output 2. Now, my output will turn on right away. The second I put the PLC and run, my output will turn on. And whenever I push the second input, input number 2, whenever he says 0, 1 because the PLC start from 0. So this is my first input, this is my second input. Whenever I push the button or turn on my second input, it will turn off this output. That's the difference between normally open and normally closed. And that's the coil, the normal coil that turn on whenever the signal go through and it and reached it, and it turn off if the signal get interrupted. The other form of coils are the reverse coil. The reverse coil is the opposite of this. If I have, let me add it. Let me add it here. To add it under, put insert lateral element, surround with the branch. Don't put branch, surround with the branch to go around it. And then you paste your coil or you drag your coil here. So now these will act different, opposite. This will be off until I push the button. This will be on while I'm not pushing the button. And when the second I push the button and let the signal go through, this will turn off. So this is the opposite. That's the reverse output. The set coil output, let me show you here. The set coil output is an output will turn on and it will never turn off until I reset it. So set comes with reset. This output, the second I give it signal on and turn on, it stays on. Even if the signal goes away, the output stays on until I build another logic to turn it off. And here I have to use the same name. If I use output 2, for example, I have to use output 2 for a reset. So set and reset has the same name. So when it's turned on, and the condition I'm gonna be adding here, whatever condition I need here, for example, input 2, whenever I push input 2, so when I press input, so when I turn it on, it's normally closed, so the second I turn the PLC on, this will turn on, and when I press input 2, it will turn off. But if I let input 2 goes away, it might turn on again because this is normally closed. So if I actually named this one the same name, these are the same name. So now when I don't press input 1, when I leave it alone, my output 2 will turn on. I can take this off. So when I don't press input 1, leave it alone, it's not on, output 2 will be on. The second I press the button for input 1, it will turn it off. And if I take my hand off of the push button, if it's a push buttons, the second I take a momentary push button, if I take my hand out of it, it will turn close again, turn it on, and when I push it, it will open the circuit and turn it off. That's the set and reset coils. The pulse raising and pulse falling, bring it here just so you can see it. This pulse positive, pulse negative. This will give you just as fast signal. Sometimes you're not going to be able to see it in the PLC, monitoring it in the PLC. It's very fast signal, the speed of the PLC. And it turn on and it turn off right after the raising edge. So as a digital, if you think about the signal, digital signal, the raising edge of the signal will turn on, and then if the signal stays on, or if the signal turn off, this output will be off after that raising edge. This one is the opposite. When you turn the signal on, it will not turn on yet. It will wait until the signal goes off. When the signal before it goes off, then it will turn on for just a fast period, like a short period, the fast of the scan of the PLC. So that's the difference between positive edge, raising edge, and negative falling edge. Usually you will be using the normal output. I don't think so. There's many applications you want to use the reverse. And also the pulse for output. I use pulse positive edge, negative edge, or raising edge, falling edge as a contact. I use those a lot as a contact, but I don't use them as much as coil, that's what I'm talking about right here. Positive edge and falling edge as a contact. That's when you want a counter, for example, and you want it to count just one at a time. Every time you turn on a light, you want to count one. You need these in the front of it, either the positive or the negative, because if you don't have this front of the signal, the counter will be keep counting, keep adding up or down, whatever one you use, as long as the signal is on it. But if you have this in front of it, that will tell the counter to count only one time whenever the signal is switched between off to on, if you're using the plus or the positive, or between the on to off if you're using the negative. So those, as I said, is not common to use. So these are the three common ones that you need to focus on as a coil. Normal one, set, reset. And in the inputs or contact, normally open, normally close, pulse raising edge, pulse falling edge. That's the most ones you're going to be using. The other important thing is the timers. And the way you get timers from the instruction block. You bring the instruction block, you put in any rung you want. It shows you all the options that you can use for instruction block. It has a lot of math instructions. Here the subtraction, multiplication, division, addition, less, equal, not equal, equal, greater, greater or equal, move, and a lot of other instructions. The one I'm trying to show here is the off delay and on delay timers. So this is the on delay, and let me bring the off delay too. And this is the off delay. Off delay, on delay. On delay means when the signal comes to it, it's gonna count whatever timer you put for it. So here I put 5 seconds. So whenever, and you have to put T bound always to tell it this is a value of timer. So whenever the signal comes, it's gonna count to 5 seconds, and then we'll turn on whatever after it. The off delay is the opposite. So let's see. The off delay, which means when the line turn off before it. So go back to the on delay. When the line turn on before the timer, it's gonna count to 5 seconds and then turn whatever after it. The off delay is gonna wait until the line before it turn on, and after it turn off again, it will count 5 seconds before it turn off what's after it. So this line will be off when we start it, and then, for example, and then it will turn on when we start, and when it turn on, it's gonna turn on right away the line after the timer too. So this output will be turning on right away with this section. This section after the timer will turn on right away with the section before the timer. But when the section or the instructions before the timer turn off and there's no signal anymore coming to the timer, the timer will hold the signal going to the output, whatever to the right side. It's going to keep it on for whatever time you set here, and then we'll turn it off. So let's do an example. I'm gonna use the tag, the global tag that I created. And I don't need the balls. So now I have these two outputs, and I'm gonna make this normal, or I can use that. That's fine. I can use set and reset to show you. And here is gonna be the same tag, test. Okay. So let's see. When I turn on my PLC, this will be open, this will be open, this will close, which is gonna turn on my output number 2. So that's gonna turn on right away. And the timer, no timer will be counting yet. The second I turn on my test signal, this will turn on, which causes this timer to turn on, and after 5 seconds, this output will turn on. This will turn off, since it's normally closed. It will turn off, and since it turned off, my timer will count for 5 seconds, and then we'll take this signal off. And when it takes it off, since this is going to be on, this will turn off. So let's try it. Now, since I'm connected to the PLC, so I'm going to download. You can check your logic by verify the program or build. You build it. It's going to show you this output window. It's going to tell you if it build succeeds, if there is any failed, and if there is any problems, errors, it will show you here. Mine, it succeed, no failed. So that's mean my program is good. So now I go to download. It's gonna prompt this window because here it wants me to tell it what PLC you want to download to. Now when you connect this PLC using the USB, it's gonna generate this for you automatically. This is gonna be generated to you whenever you connect the USB adapter to your laptop. So, and this is my PLC. You expand that, you will see my micro 810. I select it and press OK. Down here, you will get a message. The controller is in remote run mode. Change to remote program mode. You always you're gonna press yes to download. You cannot download when it's in run mode. It has to go to program mode to run to download. So you tell it yes, go ahead. I'm ready to go to a program mode and download my program. Here in this corner will show you in the right bottom corner. It will show you the process of the download. waiting on it to finish downloading. Here you go. Download is complete. Do you want to change the controller back to run? Yes. Okay. Now my controller, if I go back to this window here where it shows you what's the mode of the controller. Right now it's in run mode. My controller is in remote run mode. So go back to my program. Here you go. So that's what I was telling you. The second I turn my controller, my tag is off. So this timer will not count. And this is normally closed. So it's blue means it's off, red means it's on. So now whatever before this is on, so everything after it will be on too. And I have this output on right now. And it's set. Here now, if I click the timer, if I click test 2 and turn it on, the way you turn it on, if it's not a real input, you can toggle this input, this contact. Right click, toggle Boolean value between 0 and 1. So if it's a tag that you generated in a local or in a global variable, and it's not a physical input, so you can force this value to on. So right here, right click and toggle. Here you go, turn on. So now my timer will count 5 seconds. and this timer were 5 seconds. This counted already, now finished the 5 seconds. So this counted 5 seconds to turn this on, and this counted 5 seconds to turn this off. And when this turned off, because this is on, it reset the output. So right now this line is on, and I'm telling it to turn off this stack. So here you go, it's off, blue, it's off. And this is off because it's normally closed. This is on because it's normally open, and I toggled it to 1. So if I want to turn this off now, toggle it back again. There you go, turn off. This will open, this will close, and here's my output. Second output is third output actually, but output number 2 is on again. One more time, toggle it back on. There you go. This is still on for 5 seconds, and then we'll turn off. This is still off until 5 seconds counted, and then we'll turn off. There you go. Turn off. Turn off. Turn on. There you go. Okay. This is for time on delay, time off delay. Now you cannot do any changes, any edits to your programs as long you are connected. And here shows you connected. So you have to disconnect the program to be able to do different other changes if you want to. So you disconnect. Now you have this screen again, and you can do more changes if you want to, and download it again. And that's for this tutorial, this video, and I'll be making more videos later about these more detail about the instructions here in the toolbox. But for now, this video was to help you start in this PLC and start your programming. Thank you very much.